Okay, now let us take our aim to that we have to find the pressure difference between first and second point. So here is the water column. This is our first point at the corner, and this is our second point at second corner. So on this water column, again the net acceleration we know by earlier conditions that it was a minus d sine theta in this direction, and a perpendicular to this was g cos theta, which was acting along this direction. So let us find the pressure difference between these 2 points. So there are many multiple ways by which you can find pressure difference between these 2 points. You can travel along this direction and find the pressure at this point with respect to this in this direction. Travel along this direction here as well and find the pressure at P2, and then subtract both the conditions P1 minus P2 to find the pressure difference between these 2 points. This is one way. Now second way is to travel along this direction. To travel along this direction from this point to this point to find the pressure difference. Both will yield same result, so there is no problem. We can solve it by both the ways. I have already discussed that by all the 3 ways the pressure is always equal in my old lectures. Do watch them as well so that you might not face any problem. I will be traveling first along this direction to find the pressure difference. So let us travel from this point to this point. Here the pressure, let us say the pressure is P1. So pressure is P1. Now we are traveling opposite to net acceleration, which is in this direction. So we will be taking negative sign. Traveling inside water, so rho water, net acceleration a minus d sine theta into let us say this length is L. So that was I was trying to say. Question which will be asked in exam will give you data accordingly. They can give you these 2 heights, then you have to travel apply the first way. You have to travel along this direction and then find the pressure difference. If they give you this length L, so you have to it's obvious that you have to travel along this direction to find the pressure difference. So accordingly you have to travel from one point to other to find the pressure difference according to the given conditions. P1 minus rho a minus d sine theta into L. Now we are here, so we will be equating to this as P2. From here P1 minus P2 rho a minus g sine theta into L. These are pressure differences between these 2 points. What you can do, let us say this height is h1 and this height is h2. Okay, now travel let us try to find the pressure by traveling in this direction as well. Okay, this is method 2, or you can say it's a way of writing pressure, a different way of writing pressure. Second way of writing pressure is to travel along this. So since this is a point where atmospheric pressure exists at this and at this point, so first we will be finding the pressure at this point by traveling along this direction. So P0. Now let us travel along this path. So here the pressure is P0 plus rho g cos theta, as acceleration in this direction is g cos theta, P0 plus rho g cos theta into h1, and finally we are here, so we will be equating it to as P0 Now similarly we will be moving along this section as well. So P naught plus rho g cos theta into H2 is equals to P2. Now subtract both of them to find the pressure difference. P1 minus P2 is equals to rho g cos theta H1 minus H2. Now I have told you these two ways by which you can find the pressure difference according to the condition. Now what's your job is to prove both of them as equal. Okay, what you can do, this is second and this is first. What you have to prove this second pressure difference as equal to this first pressure difference. Okay, so what you will be doing, first you have to express somewhere H1 minus H2 to L, you have to convert H1 minus H2 to L. This cos theta you have to remove anyhow to bring this term. Okay, so try to solve it. I have already covered or proved all these that pressure will be equal in all these ways in earlier videos. Do watch them first and try by yourself. There is another way by which you can write the pressure difference, but that will become a bit lengthier in this situation, so just try to avoid it. Try to find the pressure difference by these two methods only, by traveling along this or by traveling along this direction. So that will be, you can find the net acceleration like this. It will be perpendicular to like this. Okay, now this is the point where we have to find the pressure P1 first of all. So what you have to do, travel along this acceleration now, because we are actually trying to find pressure by alternate path. So now we have taken into consideration the net acceleration. So you have to travel along that acceleration only which you are taking in consideration. Do remember this point as well. The acceleration which you are taking in consideration, you have to travel along that acceleration only, and you have to take that length only. Okay, so from this point let me draw a perpendicular like this. Okay. Suppose this length is x. So what you have to do, I will be finding some equations by writing the pressure by third way as well. What you have to do, you have to prove this second way equal to this and that third way also equal to this first one by forming some equations and solving them. So let me tell you the third way as well. So this was our water column like this. Now we have considered this time the net acceleration. Let us say that net acceleration is a net, and that you can find it as well, a minus g sin theta square plus g cos theta square. This is net acceleration. Okay, by vectors you can find it. So this is net acceleration, which will obviously be perpendicular to this water surface. Now from this point, draw a perpendicular to this water surface like this. Travel from this point to this point along this acceleration. Okay, suppose this length is L1. So let me travel along this path. Here pressure is P naught. Now we are traveling along the direction of net acceleration plus rho a net. What is a net? This is a net, and this length is L1, and finally we are at point 1. This is point 1, so P1. Now similar way, this is 2. What you have to do, extend this water surface like this. Draw a perpendicular. Consider that this extraneous surface is also exposed to atmospheric pressure P0. Let me call this length as L2. Okay, now net acceleration will again be like in this direction only, perpendicular direction, which is a net again same. So we will be traveling P0 plus rho a net in this direction. In this direction we are traveling. Here P0 is there. P0 plus rho a net into L2 is equals to pressure at point 2. Now let us take the difference P1 minus P2 rho a net L1 minus L2. Okay. Now this is the third way of writing the net pressure, and by both three ways pressure difference must be similar, that you have to prove by yourself. Now in this third way, if you have to prove it equal to first, then you will require to eliminate this L1 and L2. Try to express L1 and L2 in terms of this L which was present here. Okay, like this you have to manipulate the data. Try to express this H1 and H2 in terms of L. Okay, so you have to manipulate the data and somehow prove that all the three ways are same. Do watch my earlier video to get a quick review of what I have told you how to do that. I will suggest you to use only this one way. Try to use this one way. Data may be given in any form. They may give you H1, H2. Try to use this way only. Okay, L you can find by this alpha. Okay, try to use this way only. This is much simpler than these two, because here you are traveling 2 times, and here you have to find a net, then travel 2 times in this to find the net pressure. So always refer this way of writing the pressure, means along this acceleration, prefer it.